start, we will start the audio and things like that. Started now?
Start हो गया.
So when you edit, you will cut accordingly. When you upload
If
the
later. इसमें mic
कर दो और
start.
So I can start now itself. Okay. So welcome to Stochastic Process course live session. And this is a time we have chosen so that many of the people who registered in this course, they are available. That's what we have chosen this slot 4 to 5. And let me wait for any questions comes from the screen, so I'll answer those questions. Oh, okay, somebody is online now. Okay. Yeah, you can type your query, then I can read it and immediately I can answer. So before that, let me introduce my two TAs. One is Nitu Sharma and the other one is Anisha Agarwal. So these two are my PhD students. I'm the supervisor for both the students, and they are the TAs currently for this course. And this course is running maybe third time, I think. So
maybe fourth. I'm taking the course second time.
Okay.
This particular course, and before that, once Meghna has taken the course, and once Puneet was there, I guess.
So yeah, I guess it may be a third or fourth time we are running this course, and this course is the elective course for the postgraduate level. That means the prerequisite is a sort of probability, linear algebra,
Statistics, and
calculus. So those who have a minimum knowledge in calculus and linear algebra and good knowledge in probability, they can do this course. So that is what our course has, some 2-3 weeks review of probability, so that whatever the base is needed for the probability part, that is taken care. Then we lift the stochastic process in the remaining weeks. Yeah, let me see the question.
There is no question right now.
Okay.
If the video is not running. Yeah, it's okay.
So in the meantime, so the importance of this course I can brief. This has applications in various fields, starting from biology and electrical engineering, and then I can think of some examples in financial mathematics. So these are all the areas in which I also worked in, therefore I can able to say how the stochastic process is used in these applications. For example, if you want to design a system in which that system works dynamically. For example, you think of how many people will use some particular cell tower in some particular place, and if you want to design the cell tower, how much bandwidth to be allocated in that particular cell tower, so that there is no or minimum call dropping happens. So if you want to design such a system, you need to know how the arrival pattern of calls to the system. That means how frequently people call. And then the second information you need it, how long people speak or how much time. Both are under variable. Both means the time in which the people start making a phone call and the amount of time they are speaking. Both are under variable. Therefore, once you have a system in which you don't know how many people are going to call, how much time they are going to speak, and what is the bandwidth to be allocated in that particular cell tower, so that the call dropping is minimum. For example, the quality of service by the service provider make some sort of 2 out of 100 can be maximum dropped. That means suppose somebody some 100 times the calls are proposed, maximum 2 calls can be dropped based on the bandwidth is not available. So you cannot have a more call dropping more than 2%. That means one can use the stochastic process nicely. That means you can make a nice stochastic model based on the stochastic process and the proper assumption and so on. Then you can create a stochastic model. Then you can get the results based on the assumptions which you made it and what are all the parameter values you supplied. You can get the performance measures, some sort of example of call blocking probabilities and so on. Then you can say, okay, if you supply this much bandwidth, this much call dropping can occur. So through the stochastic model, one can say this is the result you will get it if you design this way with these assumptions, you will get this result. So that way one can analyze the scenario before setting up the cell tower with that much bandwidth, or either you can think of more bandwidth or less bandwidth, or optimal bandwidth can be identified by doing this stochastic model. Another day-to-day life example is tolls in the highways. If you would have seen it, tolls in the highway, there may be few people are sitting and collecting the money and so on. So the question arises in such a toll system, toll booth, how many servers to be placed so that the waiting time by the vehicle to pay the fees and so on can be minimized. So it's basically operation research problem. So this operation research problem can be solved by developing a nice queuing model.
So for this particularly, we need to know even the flow on that particular road where the toll is being situated. So if
Correct.
the flow is very high, then because obviously increasing the number of servers will result in reducing the waiting time.
Correct.
But we should know the flow so that both even the servers can be optimized, minimized,
Correct.
and the waiting time can also be minimized.
Correct. So the assumptions are the information supplied to create this model. What is the traffic pattern?
Yeah.
That is the input. What is the traffic pattern? Whether it follows a very standard usual Poisson process or it is not a Poisson process. So what is the frequency and how that is happening. So those type of information has to be collected first. Then it has to be included in our queuing model. And most of the time we may not able to make the queuing model as it is, or that mimics the actual system as it is. You can make some assumptions, therefore you can make a queuing model which is solvable, in which you can able to get the results. That queuing model may not be the accurate model, but still with that assumptions we can able to get the results. then you can have a benchmark results with the actual scenario. Then you can compare how much you can go for, whether to increase the number of servers, or you can do some other configuration and so on. So that is possible by knowing the input information as well as how to make the model and get the result. Then sort of do the reverse engineering. If this is the result, if you want to have this much result, how to configure the system. So that's a reverse engineering. If you have a configuration of this type, you will get this result. If you want to have a different result, then what is the configuration to be made? So that is possible. Is there any question by this?
You can ask them.
Yeah, if you have any question, you can write down in the text message, then I can read and I can give the answer. Any other question asked by the students, by the registered people during the...
I have read a recent question which says he was asking like we are not talking about like there do exist stochastic processes which are continuous time, continuous state,
Okay.
but we are not talking about them. Maybe later we will be talking
It is
about
there.
them. Yeah,
It is
it is there, but till now we have done discrete TTMC and CTMC only.
Correct.
Discrete time like Markov chains we have done in the course till 6th, 7th
So the
week.
question is?
So he was saying like there do exist such processes. We
So-
haven't discussed about
So
them.
the way we organize our lecture is we organize a discrete time, discrete state, a discrete time, continuous state, continuous time, discrete state, continuous time, continuous state. So first we do the discrete state model with the discrete time first. Then we come to the continuous time with the discrete state. Finally we discuss the continuous time, continuous state model. So there is I think 1 or 2 weeks we are going to talk about stochastic process with the continuous time and continuous state. In that there is one important stochastic process is called the Brownian motion. That comes under continuous time, continuous state.
Yes.
So that we are going to discuss, and even we are going to discuss some applications related to those stochastic processes in the financial mathematics. Yes. Any question?
No, there is no question.
Yeah, initially some student asked what is a reference book and so on. So for stochastic process there are many books. I have used Professor J. Mehdi book, as well as I have used my own book. Whereas there are plenty of books, but based on your mathematical and probability knowledge, you can take up those books and you can start reading and understanding. But since it is a sort of introduction level stochastic process course, why I am using the word introduction is whatever we are discussing, many things are in the very basic level. There is an advanced stochastic process also. It uses measure theory. The probability level will be the measure theory level, and then many of the concepts and results, things will be discussed with the measure theory level of probability and the stochastic process. So that is advanced stochastic process. So whatever we are teaching here, that is a introductory level of stochastic process. So you can use any book which has examples and very simple theory and applications. So you can use those books. So it is not bound to use only 1 or 2 books, but still I have given some list. So you can find the similar books and you can start reading that and understand the applications of stochastic process. So the course is almost introductory level of stochastic and stochastic models, not completely stochastic process theory. Any question?
You can
Okay. So some student asked what is the exam pattern for this course. Exam pattern, I can make it as the first, it is an online course. So whatever you write in the exam in the some center in which the computer will be given, and the question will be displayed and you can answer it in the screen itself. There are three levels of the paper level. The first is very basic level or easy, that comes from the video lectures of stochastic process, this course video lectures. So if you go through the video lectures carefully, and if you understand the things correctly and listen carefully, you can able to answer the questions in the first level, that is a easy level. Then the second level is average level, that comes from the assignment sheets. So suppose you would have solved the assignment sheets thoroughly, put all the effort understanding the assignment questions, and you solved it and you got a good score, and you feel like you understand the question completely and things like that, then you can able to solve the problems in the exam, which comes in the average level. So the exam has three levels of question paper. The first level is very basic level or easy, and the second level is average. Then the third level is above the average or difficult level or little higher level. Those questions can be attempted by you and you can get the good marks if you would have gone through the books which we have given for this course. Not only this books list, any books, and you understand the concept very well and solve the problem in the exercise of those books yourself, and you understood completely, okay, discrete time Markov chain means this can be applied in this scenario, this can be solved in this way. Since the information provided in this problem is these are all the information is given, therefore the problem can be solved only this way or this way or this way. So out of these ways, this is the easiest way, therefore you have solved it. So like that, if you would have understood completely all the concepts including solving the problems by seeing different books, exercise of those books, and solved by you, then you can able to attempt those questions. They are all call it as a high level or above the average level. So for example, 30% will be sort of easy, 40% of the questions will be average, again another 30% will be of the high level or above the average. So this is the level of the questions out of 100%. And how the exams are there, that is objective type. Either it could be single option is correct or more than one option is correct, even though options are given, 4 options are given. So out of 4 options, for some questions only one option may be a correct answer. There are some questions more than one options are correct.
Maybe all are correct.
Yes, that include 2 or 3 or all 4 options are correct. So this is the option type or multiple selection type questions. Then there is another type of questions, that is of
Comprehensive type.
comprehensive type. Again it is
Like it's like there is a question theory, and then based on that there are 2-3 questions.
yes, so it's a comprehensive, again 2-3 questions, and in those 3 questions also there will be a 4 options. You can it will be a single correct answer, or single option may be a correct, or more than one options may be correct. And there is another type of questions. It's a numerical type. The final answer is a sort of a number, integer, or sometimes it may be a real number also. For example, the answer could be 0.75 or answer could be 0.5. So it could be a real number or it could be integer, and so whatever the answer comes for that particular question, so you should be fill up that answer in the screen itself. There is a
No, this time we don't have.
This
such
time we don't
questions,
have.
No. This time we are having just multiple choice questions.
there is no
No, because there is some ambiguity with this, like someone written 0 point something, and then
Like
even the
up to
approximate
decimal
answer they do make some mistake.
okay.
that's
So
all.
we have everything is either objective questions or comprehensive with objective.
Yeah.
That means there is a 2-3 statements may be there, followed by 2-3 questions. So you have to answer for those questions from the comprehensive. But still, it is options. Any questions? So somebody is writing.
No, we have asked for the questions to them.
Okay. Yeah, anything related to the program, anything related to the stochastic process course, you can just type it. Then I will answer those things. So how many are this logic? Yes.
Like, what's the importance of, sir, we can, like, importance of finding out the stationary distribution particularly? Like, there are two type of, in for particularly continuous time, CTMC, we go for finding out, there's one is transient solution and one is like
Stationary.
stationary system. What's the difference between the two? And
Okay.
okay, someone has asked something. Can you please explain interpretation of Pij and capital Pij dash Qij and order of dt in case of CTMC? I think it's a CTMC question only.
What is it?
Small Pij,
Ah.
then capital Pij dash means derivative,
Okay.
and Qij, like difference between Pijs and Qijs. So Qijs are the rates
Yes.
and Pijs are the probabilities, transition probabilities.
Yeah. So in this
Yeah, in case of CTMC.
Yeah, in case of CTMZ, we are interested to find out what is the transition probability of system is moving from the state I to J during the interval of time t. And we always assume that it is the time homogeneous model. Therefore, the Pij of t is nothing but the probability that the system will be in the state J at time t, given that it was in the state I at time 0. So it is a Pij of t means probability that xt is equal to j given x0 is equal to I. So this is the transition probability which we have to find out. But we cannot find this quantity just like that. Using the Q matrix, that is infinite decimal generator matrix, or by knowing the information about the rate in which the system moves from I to J, that will be supplied in the form of Q matrix, and you can make a governing equation. The derivation also I would have done it in the video lecture as well as the lecture. You frame the governing equation, so that governing equation becomes a differential equation. So that becomes the Pij dash t, that is equal to, or in the matrix form,
There are two forms.
P dash of t, that is equal to P of t times Q if it is a forward Kolmogorov equation. If it is a backward Kolmogorov equation, then it becomes a Q times P of t, where P of t is a matrix whose elements are Pij of t.
Transition.
So once you solve this differential equation by using the initial condition, then you can get the Pij of t. So to get the value of Pij of t, you need Qij.
Yeah.
So the Qij is the rate in which the system moves from the state I to J per unit of time. When I use the word rate, That means it is per unit of time. So since it is a CTMC model is the time homogeneous model, and whatever we are discussing with all the assumptions, therefore the Q matrix is the constant values. It is not a function of t, it is a constant. So that constant number, when I is not equal to j, Qij, when I is not equal to j, that number is nothing but the time the system is spending in the state I moving to the state j, that follows exponential distribution with the parameter is same as that rate. Suppose your Qij is equal to 4, I is equal to 1, j is equal to 3. Suppose Q1 3, that is equal to 4. That means the system can move from the state 1 to 3 with the rate 4. That means the system can spend the time in the state 1 that follows exponential distributed time before moving into the state 3. The time spending in the state 1 before moving into the state 3, that time is exponential distributed with the parameter 4. That is the meaning of Q1 3 is equal to 4. Just now I explained when I is not equal to j. So always you can have the interpretation of Qij for I is not equal to j. There is no physical interpretation just like that for Qij when I is equal to j or Qia. So what we do is always Qia is nothing but minus summation of adding all the Qij's when I is not equal to j. That means that is a negative value, so there is no meaning out of it, but still I can use that also. Forget about the minus. Suppose I get the value Q11 is equal to minus 6. Suppose Q11 is equal to minus 6. I can say if the model is a irreducible CTMC model, irreducible Markov chain, the time the system spending in the state 1 before moving into any other state, that time is exponential distributed with the parameter 6. If Q11 is equal to minus 6, that means if the model is a irreducible model, that means every state is communicating with every other state, that or I should not discuss in which the system is absorbed into some state. If that is not the case, then whatever the number I am writing with the minus sign, that is the number which is related to the time spending in that state before jumping into any other state. That follows exponential distribution with the parameter that is same as the without that minus sign.
Okay. Hardik also asked about big O of dt, that is order of dt. What is this term? So
Okay, since that is a typical mathematical word, there is a two different order of t or so the small o what we are using.
we use big O only.
Yes, so
It will tend to 0 as
yeah,
dt
so for
tends
us
to 0.
the every quantity is a probability quantities. Therefore even if it is a some series with the function as t tends to infinity, we are writing order of t.
Yeah, order of dt. Order of dt. In Poisson process, we use order of dt term, na?
Order of
Like,
order of delta t.
Order of delta t.
Okay.
Delta t.
So in the Poisson process, if you write order of delta t, that means the delta t is a small increment. So whatever the expression you are going to get it in the right hand side, that will be a series as a function of delta t. That means delta t,
Powers
delta
of
t
delta.
square, powers of delta t, and so on. So as a delta t tends to 0, all the terms will vanish, you will get the value 0. So in all our calculation, we need order of delta t in which it will tends to 0 as delta t tends to 0, and the delta t is a very small increment of t to t plus delta t. So we go for always delta t tends to 0 means it's a small increment of time. So that always values goes to 0 as a delta t tends to infinity. Sorry, as a delta t tends to 0. There is another order of delta t which will go to some constant, need not be 0. In probability course, we always need a order of delta t such that order of delta t tends to 0 as a delta t tends to 0. We don't have anything related to constant which is other than 0. Fine.
Okay. And there's another guy who is asking, like he's saying he's from Chennai and interested in math a lot. He want to crack CMI entrance. Could you please help me regarding the coaching I need? I guess this is not the question related to our course. And will National Olympiad exam help me for my entrance preparation? It's not relating to the course anymore.
No, please, we cannot answer at this point things related other than this course. Next. Yeah, any other question?
You can answer Meeta ma'am's question.
Yeah, what
Difference
was the
between
question?
transient.
Yes, difference between the transient solution and the stationary solution. Sometimes when you develop a model for some system, when you develop a model, you may be of two interests. One is what will be the behavior, the dynamic behavior of the system over the time.
Yeah.
That means the instant time. Over the time, how the system is going to be behave. What's the dynamic of the system. So that can be captured or that can be studied by the transient solution of the model which you prepared for that system.
Okay.
The other interest is what will be the behavior of the same system in a longer run. Suppose this is the way it behaves, what will be the scenario for larger n or for larger time, or as n tends to infinity, or as a t tends to infinity. So there are two types of behavior. There is a two types of there are two interests to study. One is the instantaneous behavior or long time behavior. So the long time behavior can be studied by the stationary distribution, and at any time behavior, instantaneous behavior can be studied by the time dependent behavior. Two things are while studying it is different. For time dependent behavior, you don't make any assumption. Always as the dynamic of the system, you can able to get the results what is the time dependent behavior. But for the stationary behavior, unless otherwise it satisfies some conditions or some assumptions are not satisfied, the stationary may not exist. That means the system is blow up or the system is not stable. That means if the system is not stable, then you don't have a way to study the stationary distribution. When I use the word stationary distribution, that means that the whole unit mass is distributed over the some points in the real line. Therefore, the summation is 1. Then you can say that this is a distribution. If I am not able to capture some points in which if I add all the masses or all the measures, if it is not going to be 1, it could be defective also. So whatever we are studying, it is not a defective one. So it is the summation has to be 1. But if you are not able to make that, then the distribution may not exist. So there are some model in which this distribution may not exist. In that case, you cannot go for studying that stationary distribution. That means the stationarity may not exist. So stationarity means a time invariant. That means the system runs for longer time. You don't have the time invariant property. Then you cannot have a stationary distribution at all. Or similarly, the limiting distribution or the equilibrium distribution. Though, what is the meaning of these three? different meaning of these three, how one is different from that, that also we explained in the lecture. So if you go through again, then you will know all three are not going to be same: stationary distribution, limiting distribution, and the equilibrium distribution, unless otherwise the system is stable, ergodic,